Fantastic. Let's go. Um, Hi, everyone, and welcome to today's webinar, Vision Language Models, How to Leverage Google Gemini in Your ML Data Pipelines. I'll start off with some introductions, but first it's really nice on behalf of Oncord to welcome everyone who's joined today, and thank you for coming and joining the conversation on VLMs and Gemini in particular. So we'll just start with some introductions. My name is Oscar. I'm one of the ML Solutions engineers here at Oncord, and I'm very excited today to dive into Google Gemini and speak to Frederick about how it can accelerate your machine learning pipelines. Frederick, would you like to do a quick introduction?
Hey, Oscar. Thanks for having me here. I'm very pleasant to be here. It's one of these topics that I really, really like. So yeah, I can give you a short intro. So I'm the ML lead at Oncord. I have a PhD in generative models. Before all these very popular LLMs, but the foundation is basically the same still. So that's nice, at least for me. I've been with Oncord a couple of years, and recently we've been paying a lot of attention to all these multimodal large language models, which is also the topic of today. So yeah, again, very happy to be here. Very excited for what we're going to be discussing today.
Fantastic. Thanks for that, Frederick. Yes. So let's have a look at the agenda and what we've got in store for today's session. So there are a ton of multimodal models out there. So we'll start off by making sure everyone is clear on what we mean by a vision language model. And then we'll talk about how they are built and who is building them. And then we'll really focus in on Google Gemini and how it can be easily integrated into your annotation pipeline within Oncord using the agents functionality, which we're really excited about. And then using these agents, we'll show some of the ways that Gemini specialism can be leveraged to easily assist with annotation and some of the cool use cases that we can use with Gemini. And if there's any time at the end, we'll try to address questions sent in by the audience. And so please, if anything comes to mind during the session, then please send those through. And thanks to all of those who sent through any questions beforehand. Thank you. Perfect. Let's jump in, Frederick. So for those who are joining our webinar series for the first time, let's get started by saying, what do we mean by a VLM?
Yeah, that's a really good start, I think. So what we like to think about as a VLM is these language models, large language models that we sort of probably like for real learned or got to know a couple of years ago, or like 1.5 years ago with some of these GPT models, which is an LLM that is a model where you can instruct it to do anything and it'll answer as good as it can. So it's like text in, text out. Now, very recently, there has been this trend in also including other modalities than text to these large language models. And that's what we really care about here is these visual language models. So now it's not just text in, text out, but it's text and other modalities in and text out. That's the kind of models we pay attention to here.
Very cool. So it's not just, I'm thinking about maybe a like home assistant that will have a camera and a microphone, and it will take an array of input and can process those in parallel. The thing that we're interested with VLMs here is the ability to fuse this information together and give it that additional context, right?
Yes, that's a very good summarization. So it's this sort of juicy conjunction of all that information in one place at the same time that allows the model to do some very powerful sort of inferences or guesses on what to do. Super powerful, super exciting. So that could, for example, be a video feed and text. Yeah.
Well, I think we need to dig into what some of those juicy use cases are, and so let's look next at what VLMs actually do. Like, what are they being used for at the moment?
Right. So I think to take a very sort of classical example, perhaps if you're a software engineer, you already did the sort of fridge app exercise somewhere in school or the like. You're like, okay, I have a fridge. It's full of items, food items. So now the question is, what can I cook? for dinner. And in the sort of software 1.0 approach, you would have some sort of algorithm that would look through all your recipes and try to somehow select the best ones depending on a list of things is in the fridge. And that might work, it might not. And then at some point, these LLMs, they come along, right? So now instead of writing an algorithm to look through your database of recipes, maybe you just tell the LLM, I have these things, what can I cook? And then it'll take care of the rest, basically. And so that's the sort of the second step in the journey. Now, with these VLMs, you can do even better. So what you can do now with this fridge example is that you can not just write a list of items you have in the fridge, but you can also give it a visual sort of understanding of what is it. So you take an image of whatever's in the fridge, or maybe the door on the fridge does it itself. And then the LLM will be able to reason about what is the quantity, what is the quality of what you have in the fridge, and it can provide a sort of much better answer to your question. So that is basically the idea. Now you don't just put in some sort of text or a list of things within your software stack, but something completely arbitrary, which is this image, which can be anything. And it gives a lot more context to the model because it can join sort of the textual information about what am I trying to achieve. Maybe I can even tell it I care about having something, it's Friday and I would like something juicy, let's say. And then it can take that into account as well.
Very cool. Yeah. So I suppose the thing that's really exciting then is this ability to move one step closer to the general reasoning that we as people make when we approach the when we look at our fridge, or when when we're driving or doing kind of these everyday tasks that require a kind of human level of logic. And I suppose, like, in the next sense, then we can maybe take a look at why vision gives us this ability to kind of reason beyond what we get with language and these kind of lists of objects that we talked about beforehand.
Yeah. Let's start with just looking at the slide here and sort of think about it from a slightly more abstract perspective, and then we can maybe take a concrete example afterwards. So there's this sort of, I guess it's almost a famous quote now by Jan LeCun, where he likes to compare the sort of information bandwidth of language as we perceive it as humans as compared to vision. So if you are a sort of an average human or an average adult, then you will probably read around 270 words per minute. And if you sort of compute how much information that is with some sort of information theory, then that would amount to around 12 bytes per second that you can sort of ingest of information. While if you sort of measure on the nerves in the eye, how much information you're gathering with your eyes just by looking, then you're at maybe 20 megabytes. And so this is like 3 orders of magnitude more information, right? Every second you can absorb just via your eyes. And kind of the same idea applies to all the data we have digitally. And it does so for the following reason. If you want to write text, it's similarly slow. If you want to capture video, it's just about, starting the video camera, and then you're actually capturing at this level. So that means that we can only generate so much text as compared to image or like visual data. And so if we can find a way to leverage all the information that is video, then that would, just because of the scaling laws of data, then that would be so much more powerful than only having text as our sort of context or our learning material as a machine learning engineer. So that's sort of the high level idea. Now, you mentioned before driving a car, right? Imagine you have a driving assistant in your car, and it needs to get everything by language, every information of the context by language. You would basically be game over, right? Like if you were to describe everything you saw before you could, have a reasonable answer, then that wouldn't really matter. It would be too late, I guess, because you are, moving past the traffic. And so if you could have an assistant that also understood the visual input of, a camera looking out the front window, that would be so much more context and so much better responses to your queries.
Wow, so much. There's so much in that. I think the ability to process more information really tracks with this idea of why we're interested in VLMs to be a more general reasoning tool, because I suppose with that more information, they have that broader context that we as humans maybe take for granted. And something else you mentioned, you talked about the scaling law. Do you want to dig into that a little bit more?
Yes, of course. So actually, Peter, I saw in the Q&A thread, he also mentioned that there's just not enough text training data. So one of the exercises that all the big companies are doing right now is quality assurance on their text training data. And the reason for that is there's simply not that much more text you can scrape from the internet. You can only make sure that what you show the model is something that is of high quality. Like I'm kind of hand wavy here, and it is sort of generalizing perhaps quite a bit, but that's sort of the general idea. Now with video, you can, like, there's no limits basically to how much video you can get, and so if you could leverage that, that would be fantastic. So I just wanted to put a couple of thoughts on that. Now these scaling laws, they basically show something along the lines of the fact that we have seen a very clear trend for all these LLMs that with exponentially more data, so that means, you know, if you double the data, let's just think about that, then you'll get a linear increase in your performance of your model. So that means that every time you want to take one, let's say percentage, not even percentage, you want to take one step in a linear line on the performance, you need to double your data, right? So you don't want to take that many steps before doubling data becomes completely infeasible. Now, at least that's the story for text, right? It might be slightly less the story for video because you can capture so much video. And then there's, of course, a lot of sort of, religion about, is video then that good? Because there's a lot of redundancy, right? If you have two neighboring frames, they will be almost identical. Is this something you really want to use? Because that's kind of low quality data in some sense. At least it's not that rich on information. And I mean, I think it's a good idea. It's still very much a religion, so that's going to be something for the future. So,
no, it's super interesting. I think that that ability to pass multimodal information, the need for that is really clear as you're growing with the amount of data that you're handling as people, and we need to find what's interesting and extract the key points as humans to interact with, and then also that ability to communicate efficiently with end users, who I suppose are in most degrees people, to give that output in a way that we can quickly digest and process the information. I like that example you gave about the driver's car nudging scenario.
yeah, and of course it's not just video, right? It, like, eventually it's going to be all sorts of things that we can record fast. It could also be protein data, which is moving really fast at the moment as well, or it could be all sorts of other modalities, right? It doesn't have to be visual. It could also be physics or whatever, sensory data, any sort of modality.
That's very cool. I think before we start looking at different modalities, we should maybe consider then take a step back and look under the bonnet of these VLMs and say how they actually work. So we've talked about that they can process this text and language data, text and image data or video data together. How does that actually happen?
Yes, what typically happens, and now we're going to look at somewhat a vanilla example, because there are all sorts of tricks to do ensembles and all, like, other magical machine learning tricks to make it more sophisticated. But this is sort of the vanilla idea. You have a big model, which is this thing we are looking at on this picture, and it has various different components that understands different modalities. So in this case, we have a visual model, we have a language model, and they have each their own responsibility. And the responsibility is to take the input of that modality and compute embeddings. For images, that happens by cropping up the images in small patches, and for every patch computing an embedding. For text, it's kind of the same. You take a sentence, you chop it up into small pieces called tokens, and you compute an embedding for every one of these tokens as well. And then what the goal is you want to sort of mix all these embeddings in one big list. That's what we have roughly in the center of this figure. And the embeddings need to be in a way where this last component, which is typically the decoder, it can sort of understand every one of these embeddings as if they were coming from the same source, basically. So, you know, an image embedding of a cat needs to be roughly the same as a text embedding of the word cat. It so happens to be the way that we have all these LLMs, that's the language models. And we also have a bunch of visual models that use something called, for example, contrastive pre-training, where they learn how to align captions of images and images in this kind of embedding fashion, where captions, they match their associated images. And so these two types of embeddings, they don't immediately speak together. What you need to do is you need to do some sort of fine-tuning or alignment of the two types of models. And that might be even more sophisticated if you have more modalities, obviously. But that's this little blue thing right in the middle of the slide. That's this projection layer you need to train. And it's like, it takes like 1% of 1% of what it takes to train an LLM to do this projection fine-tuning. So it's very cheap. And so we can all leverage all the sort of open source models for both visual and language models to build our own VLMs, basically.
Okay, so if we have an individual language or vision model, the only thing that we need in order to create this VLM is effectively a mathematical translator between the two to communicate between these embedding spaces. That's really interesting. And how then does the performance of these models change with the performance of the vision and the language components?
Yeah, that's another very good question. One of the things we've seen recently is that these visual models that are trained with these image and caption pairs, they tend to sometimes have blind spots. They have things that they just don't pay attention to because of various reasons. So it highly depends on the models you use because of the way they're trained individually. And so that also means that you need to be very careful when you select these backbones. One of the things we've seen recently is that a lot of open source VLMs, they rely on an image backbone called CLIP. And that image backbone has a couple of blind spots. It's very bad at determining orientation. So if you have a dog positioned in two different ways, it won't really know the difference. And the VLM will basically inherit that blind spot. It's something that we have seen many of the closed source models sort of avoid and alleviate somehow. We obviously don't know how, but yeah, so that's one of the things. But fortunately, there are open source models that also deal with these problems by now. It's moving really fast.
Very cool. And I think that kind of brings us nicely as we start to hone in on Gemini, which is our kind of key topic today. You can maybe give us a minute or two on these open source versus closed source models, some of which we can see on the screen right now.
Yeah. I mean, there are obviously many ways in which you can compare these models. One is just like ease of use. And I don't know if anyone of you out there have sort of experience with using these models. You probably you do already. Closed source is typically really, really easy. You just need an API key and then you're up and running. And you have an endpoint and you can send whatever and you get a response. That's really nice. You don't have all the hassle of open source models where you need to host the model. You need to actually have storage, a GPU that has enough VRAM to actually host all the parameters or do tricks of like quantization or whatnot to make it work. So that's obviously sort of the nice part about closed source models. The perhaps not so nice part is obviously the security concerns. You're told that they won't use your data for anything, but they do still see the data. So if you are HIPAA compliant or you have some other sort of a security certificate that you want to take care of or protect, then you might not be able to use these models. And that sort of brings you to having to use the open source models. Also, we have also seen that on many sort of common benchmarks, the closed source models are just better. Up until very recently, there's like one or two models that do very, very well that are still open source. One of them is this intern VL, the one listed in the bottom here. I would encourage everyone to sort of have a look at that. It's actually being presented at CVPR in a month or so, if anyone is going there as well.
Very cool. Yes, I think we'll be there as well. Very exciting. Excellent. So now we've looked at these closed source models and maybe some of the concerns that we have with them. Why then are we looking at Gemini in particular today?
Yeah, Gemini is sort of catering to to almost everyone, I guess, in the sense that it's easy to use and it's also sort of an integrated part of the Google platform. So if you're a Google user already, then that's perhaps also nice. But some of the things that we really like about it is one particular thing, and that is it has a very big context window. What does that mean? It means that you can, in a query, so when you're writing something that you want your VLM to do, you can give it a lot of context without training anything, and it'll be able to use and leverage all this information. So you can, for this model, you can use like 1 million tokens. So that would be 1 million patches from images or 1 million, small pieces of text. And that suddenly enables us to, look at many documents at once, or videos, for example. It's a composition of many frames, so you need a lot of tokens to analyze videos. You can use sensory data from like a long period of time, and so that is really powerful. So that's why we really care about it in this case. We will see a bit more in a second, I guess, but the obvious, like, it's like a trade-off, and then we'll see that in a bit.
No, that's really interesting, and I think that long context window ties in nicely with the idea that we were thinking before about the speed at which data can be passed with visual data versus language. In that, if we can have this longer context window, then we can pass more of this video or text or image data, and then have a better general reasoner. So that's that makes sense to me. And I think it's probably a good time, as you hinted at, to maybe look at how Gemini compares to some of its predecessors and maybe a competitor as well.
Yeah. I brought in this slide not because I wanted to, run through all these numbers. What I wanted to mostly show is that it performs really well, actually, in the first place. So compared to open source models, although they're not listed here, it does very well. It beats most of them. But there's also something a bit suspicious about their image benchmarks, and that is they report a lot of benchmarks that are not really a part of the sort of general leaderboards, which is a bit weird from my point of view, at least. So all the numbers on the right column with the red stars are numbers I had to sort of go find somewhere, which is basically not official. And on all these benchmarks, or at least most of them, GPT-4 actually does better than Gemini, the new Gemini model. And this GPT-4 model is from March 23, so it's like a year old. So that's a bit, it tells some sort of a story. But that said, these are all image benchmarks. So now we are talking about looking at an individual image. While if you then look at video benchmarks instead, which is what we're going to be focusing on today, then it's a different story, because then GPT suddenly, and this new model, it suddenly does way better than most models. And GPT-4 can't even report many of these numbers because it cannot handle this amount of data in its context window. So some of the numbers are highlighted. It does better than most models, even better than their ultra model version 1. So that's extremely cool. And I think I would much rather maybe just look at one slightly more concrete example. So maybe if you can go to the next slide, then I think we'll have something to talk about. Right. So what are we looking at here? I'm going to start by looking at the plot to the right. So what the plot shows is on the x-axis time, and on the y-axis it's some sort of complexity. It doesn't really matter because you can see there's not really any variation on the y-axis. But the idea is that if you have a video and you hide some piece of information somewhere within a video, then you ask these models to actually retrieve the information afterwards. Then Gemini does a really good job. It can do up to like 3-hour videos, still find a little piece of text in like one frame somewhere within these 3 hours, and sort of recall that when you query it. So that's called like a needle in a haystack kind of experiment. And I think that's really, really cool. So you could probably already, if you're sitting as someone who's dealing with data, you have a big data lake, you're looking for something specific, you could probably find it with these kind of models because it has such a big context window. And GPT-4 just doesn't have that. It can do a couple of minutes and that's it. So you would have to chop everything up in very small bits if you wanted to do the same thing.
That makes sense. And if we're thinking about a kind of classification case, if we had a video, then we want all of that information to be considered if we were thinking about using a VLM as a classifier to extract the information. And I'm talking now as a data annotation or even a data curation piece, that you want to be able to find the key points in a video that are of interest. You know, you can see there you've got a video that's up to an hour, up to 3 hours. You want to be able to extract the key points from that without having to slice it up and losing the context from those other files. And so I suppose with Gemini, what are the other, we talked about the fact that some of these VLMs can pass outputs other than text. What else can we get with Gemini?
Yeah, Gemini, it has a really good understanding of JSON, which is something we'll see more of later. And that is extremely powerful. With open source models, we can do tricks like we can mask outputs in a way where we ensure that we will get a valid JSON in response. With Gemini, you can just set a flag when you call the API, and then you are guaranteed that it'll only return JSON. That it sounds kind of dull, but it's extremely efficient if you want to do structured data extraction from your videos, from your data in general. That you can sort of not just make sure that you get JSON in response that you can sort of try to pass, but it actually also understands JSON schemas very well. And that means that you can also sort of define how you want the JSON that's returned to look, or what is the structure you expect. So that's really cool. We're going to see that in a bit. Another thing that it has, GPT-4 also has that, it's like function calling. Again, it's a really smart feature that you can tell Gemini that it's allowed to use one of your local functions on your own running machine as a part of computations or as a part of registering specific events in a video, or in other ways sort of interacting with your system. So you sort of allow Gemini to be the one calling you rather than the other way around. And then there's a final bit. It's kind of, we have listed good calling requests, but there's also like a bit, they have an AI studio where you can iterate really, really fast, because you can generate a prompt and see the response. And then if you like it, you can collect it. And then over time, when you're interacting with the model, you'll be collecting data. And then for the 1.0 models, you can actually use that to fine tune the model. And that's why I have a sort of like we have crossed the last one, because I guess it'll be coming. That would be my expectation. And so there's this very nice sort of translation into fine tuning, but there's also a very cool translation into code. So you can take your prompts and then you can click generate code, and then you'll just get the code in Python that does that thing you've been doing all along. So that's another really, really cool feature.
Very exciting and cool to get some Gemini feature requests out of the out of this session as well. If anyone is watching, you can make those happen. Cool. So we've kind of focused in on Gemini and why we're interested in a kind of data curation or annotation case, and maybe then we want to think about how in Oncord we can integrate Gemini and actually see some results. So we at Oncord have these new custom agents, which effectively allows you to bring your own action to the platform. So you can set up whatever action you want to trigger, whether it's through the SDK. You can set that up as a cloud function and then just trigger that with a webhook and call that directly through the platform, which is super exciting and something that we're going to use with Gemini today, if I am not mistaken, Frederick.
Yes, we are. That's for sure. So I thought, why not just take a look at what it actually does, and then we can maybe show the juicy stuff first, the cool feature, and then we can sort of break it down a little bit afterwards. How does that sound?
Very exciting, very exciting. I think we're going to get a live demonstration from yourself, so I'll stop sharing and let you take over.
Awesome. So let me find my screen here.
Fantastic.
All right, can you see it?
Yeah.
Just need a way to remove you guys. Sorry, just a second. All right, there we go. I'm ready. All right, so we are here. We are within the label editor of ours, and I have defined sort of an ontology that I would like to have filled out for this particular video. So the ontology comprises different things. It has like a textual field where I would like a summary of what's going on in this frame. I would also like to know if anyone is jumping in the water at this particular time. Maybe I have some security concerns or whatever for the sake of the exercise. There's a radio button. I also want to collect different properties along the frame. So it could be something like, does it contain fish? Are there any snorkels? Does it have any people? Can we see the water actually? And is it indoor? So what we can do with these custom agents is, as you mentioned, you can set a custom webhook. So that means I control a server somewhere in the world. It's not within the Oncord environment. It's somewhere and it has a public URL. That public URL can be triggered from within the platform. So I have created a couple here. I've made one with Gemini where I just want to, get the top level classifications for this particular frame. So what will happen is that this will go off, tell my public URL somewhere on the internet that now things is happening. We are on this frame in this particular project. Would you mind doing your thing? And then the idea is that the agent can do basically whatever. So perhaps you saw that we had a bunch of different here. We have some stuff about OCR and all these things. Yeah, I know the results are in. But you could basically imagine doing whatever. It could also be some sort of quality check of the labels you have done already. But in this case, I just asked Gemini to fill in all these different answers. So here we are. We have a summary. A water polo match is taking place. Yada yada. Is anyone jumping in the water? No. And so on and so forth. And so this agent we built here, it understands both checkboxes and radio buttons and text fields. And you could do that in sort of any way you would like, I guess. It could also be your own model of some sort that does segmentation. Yeah.
I mean, this is super exciting, right? Because definitely as somebody who's interacted with some of these VLMs and like I've uploaded an image and asked it to give me some context and it gives out that kind of free text. And it's often the long sort of summary field that you can see there. But the ability to get these VLMs or Gemini in particular to give us a structured output. And so you can see there that we have the single choice from the list and then the multiple choice as well. That's fantastic from an annotation point. That's really, really, really exciting. Very cool. And I suppose like now can you show us how to do it?
Yeah, I saw so Pei just asked if you can sort of adjust the categories. And yes, you can. So you can, it'll basically understand everything you put into this list in your ontology, and it'll just go ahead and do it. And yes, I think Oscar, we should actually jump in and see how we do it. Yeah.
So it can also reason based off of whatever your ontology fields are, right? Is that what you were saying?
Yes.
Wow.
And I'll show sort of the details of how we did it for this example here. And then I can also sort of reveal that we have some sort of dynamic logic going on that we will also most likely share at some point. I think we'll do it with another webinar. So it might not be today, but I guess if you're interested, I'd be happy to share it. Yeah, so let's dive in. I wanted to start with something very basic. So let's do the hello world, I guess, back to the engineering classes. So the first thing you would need to do if you want to run Google Gemini is install their library. We have these notebooks. We're going to share it afterwards. So if there's something you didn't get, you can always come back and run it. There's a Python library called Google Generative AI. We install that. And I've also installed Oncord, the Oncord SDK, to be able to interact with the labels. Great. So you get an API key somewhere. There's a link here if you don't have one. So you can just go there and and get your own. I'm getting it from my secrets in here, so I'm not going to show you that. And then you configure Gemini. And so if you want to run a model, then maybe I make this slightly bigger, like so. Then what you'll do is you'll create a generative model. You'll give it the model name. There's also a way to query what models you can use. And then you can start a chat with the model, give it a history if you want, if you have some predefined history that makes sense. That's one of the things that I talked about with the AI Studio, that you can sort of define this history by just interaction. And then you can put it here to give it some sort of in-context learning abilities. And then you send off the message and you get a response. So let's try to see if the connection is still open. So I just asked it here to say hello world. So that's my prompt. Please print hello world. And so it does. That's fantastic.
Cool. So that's the equivalent of going into the UI on Gemini and asking for a response, and then it outputs it. But here we just have that as a as an API connection. Yeah.
Yes. And then because this is kind of a TV kitchen thing, I thought we would also show how to deal with images and videos. And so what I've done here is I have prepared a small function that can upload an image to the Gemini via the API. And then you get a sort of a file that represents that image. And you can add that to the message. So the message is just a long list of files and text. So it's the image and the text here. What type of animal is this? So this is still kind of very vanilla. But yeah, so now we send over an image and we ask it, what is it? And it's a wolf. So it's still like a very sort of sandbox in the sense that we don't have any structure on the output, right? I couldn't just take this, not without a lot of, I guess, guessing and algorithmic shenanigans to turn this into, checklists or some sort of classification, right? So it would be nice to put some more structure on it. Then the next thing we would want to do, I guess, is see how they deal with images. Oh, sorry, videos. And videos are done in a very similar way, but to also do the integration with Oncord, what I've done is I've created this small utility that can generate an SSH key for me here. And then I'll go and add it to Oncord. If you just follow the instructions here, you can do the same if you're running it afterwards. And then what should be possible afterwards is then grabbing a project via the Oncord SDK. I'm going to find the one that's called Gemini Demo. So you might not have this if you're an Oncord user already. You can use your own. And then I'm going to get the actual project. I'm going to get the first item from the project, which is a video by chance, or by pure luck, I guess, in this case. And then we can do the same thing. So we can upload the frames to Gemini. So the utility is just going to extract a frame every second, and then it's going to upload it to Gemini. And that's actually how the Gemini team, they advise everyone to use videos. So it's not like you're uploading the entire video. You are responsible of extracting frames, and you will submit them to Gemini like this. So you'll have a timestamp when the video is this frame and what is the file that you uploaded to Gemini, and you can have a long list of those. So that's how it works. You can add that list of frame numbers or like timestamps and frames along with a question, and then you should be able to get a response based on these multiple frames. So now the user query is slightly longer. It's a bunch of frames here. This guy's riding a bike, he's falling into the water, he's doing it again, and he's falling into the water. And then I ask for a summary here, and it says that it's a young man riding a bike, he's jumping into a pool, he does it multiple times. So that's sort of how you analyze videos.
Very cool. And so just somebody has asked if this notebook will be available online, and we'll be making this available after the webinar today. Excellent. That's really exciting. And actually, we'll jump in with a couple of other questions that are kind of relevant to where we are now. So we've given it a prompt at the moment of a video or an image. Could we possibly give this Apologies. This is the output of a bounding box. We'll maybe come back to that when we look at the segmentation case at the end. I'll let you continue, Frederick.
Okay, cool. So maybe one word I can put on that question already is like, can you get a bounding box from from Gemini? Sorry.
Yeah.
And the short answer is more or less no. It's very like it doesn't want to give you bounding boxes, but there are ways around it. You can sort of fool it to do something meaningful still. We will discuss that in the end. All right. So now, sort of from a high-level perspective, what we have now is sort of a sandbox thing where you just play around with it. You get some unstructured results. So wouldn't it be nice if we could put some more structure on what we get in return from Gemini? And that's exactly what this next part of the exercise is all about. So we will be using JSON output. Now, for those of you who are familiar with Pydantic, this will be completely obvious. But for those of you who are not, this will be completely magic. So Pydantic is this Python library that understands very well how to translate from JSON to Python objects. So real Python objects that have, floats and ints and strings and enums and these kind of things. It's used a lot in like API, stuff like that, where you need to transfer data over the wire. So what you can do with this framework is you can define a Python class and you can give it fields and tell what the type of the field should be. So in this case, I'm saying this field image class, it can only be these 5 different strings, 4 types of wolves, and not a wolf. And then the magical part here is that you can ask this Pydantic class now for a JSON schema. So if you do that, now I just dump it here, you will actually get that definition, but as a JSON schema. And as I mentioned before, Gemini understands JSON and JSON schemas very well. So that's really, really cool because you can go one way now. You can go the way where you go from your Python code to something that Gemini understands very well. And it turns out that you can also go the other way. So afterwards, you can also grab the JSON you got from Gemini, use the same class to pass the JSON into a Python object. That makes sense. So now when you have done that, you will have something in Python where you can trust everything you have in there. So if you have a field that's supposed to be a string, you know it will be a string. If you have a field that's supposed to be a list and you set certain criteria on that list, you know that will be sort of a valid list. Right.
So definitely there was one question on how people can adjust these class categories, and I suppose that answers it, right? So through these Pydantic models, you can force whatever output you want from Gemini and output that as a JSON. Very cool.
Yeah. So in this case, right, I just typed in these 5 different things. It could have been anything, and we're gonna see a couple of different examples on how you can sort of adjust it. I wonder what's going on here. This is not good for a demo, Oscar. So this is one of these things because Gemini 1.5 is a preview. Sometimes you run into these issues. I think I have most of the responses cached as well. So hopefully we'll manage still. Right. So the purpose here is just to say, okay, now you can build a system instruction. So when you instantiate one of these Gemini model instances in your Python code, you can give it some system instructions. And in this case, I just tell it, please respond only within this JSON schema. So that means that now I get something in return that I can actually pass. Let's see if I try again. If I'm lucky. Sometimes it's just there we go. Okay, the first one worked at least. Right. So this time I gave it this instruction: follow my JSON schema, and so it did. Now it said in pure JSON, this is a gray wolf. Right. And it didn't choose something arbitrary. It chose exactly what I asked it to. So that's really, really powerful, and just for classification so far.
Very cool.
Now, I think one more thing we need to see before we pause is that you can, of course, do it for very many different things. And this is actually where it becomes some sort of prompt engineering again. So Pydantic also allow you to define, see if we can find one, these fields. So this is a sort of more verbal description of what is it that you expect. So in this case, instead of this image class, it's the same as before, the same 5 categories, but I can also add a description, and that description will be passed on to Gemini. So that description could, for example, tell, I only care about, the players on the field, or I only care about this or that, or I expect you to tell at most 5 things. You could also give restriction on what is the length of the description I expect. And Gemini will see that in the JSON schema as well. So now you can put even more structure on the way you expect the data, but also try to guide Gemini even more by adding these descriptions.
If we think about that then in the context of what we saw in the Oncord platform, is these are all things that we could set up as part of our custom agent, right? So if we wanted to put these minimum lengths or add in the text prompts as well as the image or video, then these are all things that depending on the use case, we can kind of, it kind of seems like this can be used for a wide range of options with this level of customization.
Yes, exactly. You can customize it to the end of the world, and it's quite remarkable, I think. It's really fantastic, and it's often what does makes the difference. Had I just removed all these additional field properties, excuse me, it wouldn't have worked as well. It works better when you give it more context.
As we've seen with other LLM kind of prompt hacks of, that this is really urgent, this is really important, so we can allow that boosting here too.
Yes, exactly. I think there's somewhere in here where it says, please take your time, generate the best response you can. Like these kind of things, they actually matter. So that's basically how you do this, and you can also let's try this one again and see if I'm lucky. So now this is the model that had multiple different things. So this kind of resembles what we had in the demo I showed before, in the sense that you have like a free text field. You have that's this one, free text field. You also have like an enum kind of classification, 5 explicit options, mutually exclusive. You also have this sort of tag idea of having sort of multiple choices you can do. So that's sort of the idea. It's really annoying that we have reached the limit here, but we do get to see at least some of the queries run through. So this would be one of these responses, right? Now I get both the classification and I get the description, and I also get different tags for this particular image. It's a gray wolf, it's like fallen tree, and it's wildlife, nature, these kind of things. So very, very powerful.
Very cool. And we'll just to and while we're talking about the API and the usage, we'll be sharing this notebook, but will we be sharing our API connection? No, right?
No, not the API key. They will have to get their own, everyone.
Okay.
Yeah. But there's a link in the notebook somewhere up here in the cell where you configure Gemini. There's a link to where you get the API key. So it's not too. It's quite easy actually.
I like the TV chef analogy you gave earlier. I think we're giving the full recipe, right?
Yeah, exactly. Yeah, that's what we're trying to do.
Very cool.
Okay, cool. So the last thing I wanted to show, also in the interest of time, before discussing, bounding boxes and these kind of things shortly as well, is the fact that you can also do function calling. So I just wanted to give like a really simple example. So I had this video before, right? A guy jumping in the water. Now let's say my task was to track how often does someone jump into the water. So what I can do now is when I instantiate this Gemini model, I can give it tools, and tools is basically functions. So it's a list of functions that Gemini is allowed to call. Now I have defined a function here. The only thing it expects is a timestamp, which is a string. and I've given it a doc string that'll be passed on to Gemini, so it'll read the doc string and know what this function is used for. And then I could do whatever in here. You could imagine I could, raise an alert, someone fell in the water, if it was like a security system, or I could just track in my database, this is something that I care about. I could put classifications on my labeling task. You can probably imagine where it would be useful for you. And again, it understands that it expects strings, and it will only call the function with sort of valid parameters. So very magical. Now, if I ran this, I'm not gonna attempt because then these will disappear. If I ran this on the video, what it would do is it would do something along these lines. So it would call the function twice at the third frame or fourth frame, then at the last frame. That's the 2 frames where it saw someone jumping in the water. So that's another way where you can sort of interact with the model, which is really, really cool. And I hit down here in this little expandable. This is what Gemini sees for that function. So that's why I said it's going to see the actual description. That's going to be a part of the payload that we send over the wire to Google to get a response back. It'll know that the key is timestamp, is of type string, these kind of things it's required. That's why they can assert that it'll follow the rules of that function.
Very cool, and that kind of touches on that why we're focusing on Gemini today, right? Where we have this ability to call local functions that we've defined, and it can get that context from the doc strings, which I think is really exciting as well. Actually, that saves it just seems like it has that ease of use, that which is when we were talking about why closed source models, that's exactly what you want, isn't it? Just a kind of plug and play option.
Yeah,
awesome.
Exactly.
So this is something we're going to share after the session, and I mean, we would love to hear people's thoughts and how they use it when they play around with it. And thanks, Frederick, again for putting this together. Somebody has asked if we use this package, does it mean we're going to get our video released or like leaked? I don't think so. I think if you have your own API key with Gemini, then that data will just be between you and Google, and then obviously if you interact with the Oncord platform, then that will then that will all be stored, whether you're using a cloud connection or local upload, as per usual.
Yeah, perhaps one of the things we could attach here is that's one of the powers of these custom agents that we have introduced in the platform. It's the fact that you can now use these VLMs if you're hosting them locally, and you can assert that every piece of data only shows up in the editor where you already trust it, and it's going to show up in your controlled environment on your server with your public URL. So it won't be seen anywhere in between. And in fact, like the communication between these two things, it's not even sending the data, right? Your own agent will be responsible for loading the data in the way you want to load it. So you can like ensure that it's completely safe. Also, if you don't want to use Gemini, Gemini is of course another story, because you at least send it to Google, I guess.
Very cool. Complete customization. Now, shall we just, I'm conscious of time. We have a few minutes left. We can maybe talk about and I'll share my screen, Frederick, if you can let me jump over. Earlier we talked about maybe taking an input as a bounding box instead of a video. Is this something that we could, is this something that could be done?
Yeah, I think one of the things that many of these models sort of have an issue with is actually doing exactly that, bounding boxes. There are a few of them that have been trained to for that particular task. They work okay, but one hack that works pretty well with most, at least the closed source models, and there's also a version of Lava actually that has been fine-tuned for this particular task, is a technique called set of marks. And the set of marks technique is basically you use SAM or something else to draw boundaries around the objects, all the objects in the image. And for every object, you put a small ID, like a number or some short hash or something. And then you send off that image with the hash ID and the boundaries to Gemini, and then you ask it to do things for these IDs. So give me the list of all the IDs that are people, and then you can very easily sort of filter away all the noise and only get those that are relevant. And Gemini seems to, like 1.5 seems to work quite well with that. I would say on par roughly. That's what we have seen at least with GPT-4. Gemini 1.0 does not work. Mark my words, it does not work. It's extremely bad for that particular task. Quite interesting. So I think that's something they might have noticed on the Gemini team.
Very cool. So
that could, of course, also give bounding boxes, right?
I think that's covered the top two in that bounding box case. I'm conscious of time, and we don't want to run over. So I suppose we'll just jump to this last question, thinking about, can we take in audio and other multimodal inputs?
Yeah, Gemini also supports reading audio. I think if the task is to transcribe the audio from a video, I would probably use Whisper or some other model that is, targeted for that particular task. It's cheaper and it's often better. But if you can come up with a task where both visual and sort of the audio content in sort of a symphony gives you the good result, then perhaps it's worth thinking about. Right? So it's kind of back to what we discussed already, that you need to have situations where it benefits from having both parts at the same time. So if you're trying to give a summary of a video, perhaps it's very relevant, right? If it's let's say a politician who's speaking, then both facial expressions and what he's saying is relevant.
Well, I think that's symphony of audio. And we just have one more question on language requirements. And do you have any idea if Gemini passes Dutch? If not, I think we'll probably have to refer to the Gemini docs after this.
Yeah, I guess we would have to look into the my Dutch is not good enough for me to actually test it in a very reliable way, I guess. I would say most of these models, they tend to work best in English. Some of them in Chinese, and other languages typically require some sort of adjustment. I'm Danish, so I know the feeling. It's quite sad.
And in 20 seconds, can we analyze video real time using Gemini?
I have not made it work real time yet. That's for sure.
Okay.
Yeah.
Maybe that's another feature request to add to the stack. Fantastic. So, I mean, I suppose all that's left from today is to summarize and thank everybody for attending. So thanks so much, Frederick, for taking us through Google Gemini and VLMs, and also for showing us the new custom agents in the Oncord platform, which are super exciting, really, really cool, taking a look at those as well. And on behalf of everyone at Oncord, wanted to thank you all for attending, and we will see you at next month's webinar. Thanks so much. Thanks, Frederick.
Thanks a lot, everyone.